Okay, let's finish up section 1.6 on lines by talking about parallel lines. The way you tell if two lines are parallel is you look at their slope, and obviously if they're both vertical lines they're going to be parallel, but they won't have a slope. But if you look at these two lines, you'll notice they're in their slope-intercept form and the slopes are the same, so these two lines would be parallel lines. So you can look at the graph of these two lines and see here's one line, here's the other line, and obviously they're parallel, they run parallel to one another. So that's what parallel lines will do. Now if you let's talk about perpendicular lines. Perpendicular lines are actually lines to where the product of their slopes are -1. So this line has a slope of -2/5, and this line has a slope of 5/2. And if you took -2/5 and multiplied it by 5/2, you would actually get -1. And since you get -1 for the product of those two slopes, you know that those two lines are perpendicular. And let me show you a picture of the two perpendicular lines. Okay, so here's the graph of those two lines I just showed you, and you can see perpendicular just means they cross at right angles, just like, you know, two streets generally cross one another. And you can see, like right here, you have a right angle on each corner or each side of this point. You have a right angle. So that's perpendicular lines. One of the ways that we try to make sure you understand this concept is what we like to do is we like to give you a point that a line goes through, and we want you to find the equation of the line that is parallel to a given line or perpendicular to a given line. So let's start with parallel. Okay, first of all, we know the line goes through this point -2, 3 because we're told that. And we know the line is parallel to this line, 3x plus 2y = 6. Now, you can find the slope easily. All you have to do is solve this for y. So 2y would equal -3x plus 6. And then if you divide both sides by 2, you get y equals -3/2x plus 3, which is this line. But the point, what I really needed is to find out what is the slope of this line, because if my new line is going to be parallel to this line, it's got to have the same slope. So I know my new line has to have a slope of -3/2. And now I have a point. Remember, I was given this point. So now that I have the point and I have the slope, guess what form I can use to get the equation of the line? Point slope form. So I use the point slope form. Remember, that's where you say y minus y1, and the y is 3. So y minus 3 equals the slope, which is -3/2, times x minus x1, which in this case is -2. I went ahead and just did the change of sign in my head. X minus -2 is x plus 2. Then I distributed the -3 through, so I took -3/2 times x and got -3/2 x, and then -3/2 times 2 just gives me -3. And then finally, the last thing you want to do is you want to solve this for y, and by adding 3 to both sides. And so when I add 3 to both sides, they just cancel each other out, and all I get is y equals -3/2 x. And I'll show you a picture of this in just a moment. This line here was the original line I was given, and remember, this is the point I was given, and I wanted the equation of a line that goes through that point, and this is what we found, y equal -3/2 x, but I wanted it to be parallel to this line. And notice it looks like we succeeded, because obviously the line, this line, y equals -3/2 x, looks parallel to that line and definitely goes through the point -2, 3. So we've got the right answer. Now to answer the other question, we want to find our new line to be perpendicular to this line. Now we already know the slope is -3/2 because this is the same line I used over here. So I know the slope of this line is -3/2. So I got to come up with what number can I multiply by -3/2 that equals -1. Well, really you're just looking for the negative reciprocal. And so you take the opposite of the sign. Since the sign is negative, we go positive and flip it over. So m equals 2/3 is the slope of the new line. And I'm still using the same point. So I want the line that has this slope that goes through this point. And then that will tell me the line that's perpendicular to that line but goes through this point. So again, I can use the point slope form, but this time I'm still using y minus 3 and x plus 2 here, but the slope this time is 2/3. So then I distribute 2/3, I get 2/3 x, and 2/3 times 2 is 4/3, and then I have to add 3 to both sides. Well, 3, remember 3 is the same as 9/3, so if I add 4/3 to 3, it's the same as adding 4/3 to 9/3, so that'll give me 13/3. So this is the line that goes through the point -2, 3 and is perpendicular to our given line. And let's take a look at that on the graph. Okay, I just caught something, and this is the perils of when you do copy-paste. So down here I forgot to change these because I just copied and pasted this over here and meant to change it. But the coefficient of x should be 2/3 in these last two steps, not -3/2. So it's 2/3 x here. So basically the equation is 2/3 x plus 13/3. Now let's look at the graph. Okay, so this was my original line right here, and then here's my new line, 2/3 x plus 13/3, and notice that it appears to intersect this line at right angles, and it obviously contains the point -2, 3. So I did get the correct line. There are quite a few applications that involve lines or linear equations. Sometimes you might want to use different variables to be more representative of what they represent. But let's look at an example. One of the examples that's used quite often in business is straight line depreciation. And that just assumes that something depreciates in a linear fashion. So let's look at this. Automobile depreciates linearly for a period of 10 years. It says the original value was $20,000, and after 5 years the value dropped to $16,500. Let's let v be its value. That basically will replace the y in our equation, and let's let t be the number of years, and that'll replace the x. Okay, so let's write a linear equation that will represent the value in terms of years. Now, that linear equation is going to look like this: v equals mt plus b. So instead of y equal mx plus b, I'm going to write it like this. Now, we know that when time is 0, that the value is $20,000. So we already know what we would normally call the y-intercept. Technically it's the v-intercept, but we already know that the point 0, $20,000 is a point on the graph. So b would actually be $20,000, or 20,000. Now we can find the slope by considering the 2 points on the graph. We know when t is 0, v is 20,000, and we know when t is 5, v is 16,500. So using the formula for slope, 16,500 minus 20,000, I get -3,500 over 5 minus 0, which is 5, and so I get minus 3,500 over 5, which is -700. So remember, the formula for slope with x's and y's is, remember, you take y2 minus y1 over x2 minus x1. Of course, here it's more like I'm taking v2 minus v1 over t2 minus t1. But it's the same thing. So the slope is negative 700. And now, if I want, and remember I said v, so if I want v equals mx plus b, then I'm going to have v equals mt plus b instead of y equal mx plus b. So that wasn't an error, that was just showing you the normal way, but here's what I'm doing. I'm replacing y with v and x with t. So I get v equals mt plus b. Well, m is negative 700, so I have negative 700t plus 20,000. Now I can estimate the value of this automobile at any time in the future. So part B says find the value after 9 years. Well, now I just take this v and plug 9 in for t, and so I'm going to plug 9 in for t, and that's going to give me 6,300, negative 6,300 plus 20,000, and that's going to give me 13,700. Okay, this is very similar. A plumber charges a $75 fee for a house call and $27.50 an hour. So basically, if he just turns up and shows up and turns around, he's going to charge you $75. So, what I want to tell you here is that when t is 0, the cost is $75. So that would mean that the y-intercept is $75. And here we don't really need to do the slope. We know the cost is going to rise $27.50 for each 1 hour of service. So we can say that the rise over run is $27.50 over 1, or 27.5. And using the y equal mx plus b form, we can say cost is the slope times the number of hours plus 75. And then that gives us the cost function. And then if we want to find the cost at 3.5 hours, we just plug 3.5 in for h, where h represents the number of hours. And so we get 27.5 hours times $27.5 times 3.5 hours plus $75 fee for showing up, and that gives us $96.25 plus 75, which is $171.25. I'll let you freeze the video and read this, okay, to save a minute or two. Let me just tell you that profit is revenue minus cost, and here the cost, if you read the problem, you'll find that there's a fixed cost of $5,000 plus a cost of $5 per item, so, or per dozen in this case. And then there's a revenue of your revenue would be $12.50 times the number of item, or in this case the number of dozen. So now if you want the profit equation, you take revenue minus cost, so that would give me the revenue is 1250x minus the cost, which is 5,000 plus 5x, so you get 1250 minus 1250x minus 5x minus 5,000, which would be, dang it, that would actually be 7.5x, not 12.5x. So that would be 7.5x. Let me pause it and fix it. Okay, apologize for that. Actually, that should be 7.5x minus 5,000 for the profit function. And then down here, to find the break-even point, you set 7.5x minus 5,000 equals 0, because you're finding out when your profit is 0. And then so solving that, you get 7.5x equals 5,000. And then if you divide 7.5 into 5,000, you get 667. You actually get 666 point something. So you're going to want to round up to 667 dozen. And that will basically be when you break even. It's when your profit's going to be 0. And if you any amount above that will actually give you a positive number for your profit equation. And that pretty much finishes this section on linear equations of two variables.